When we solve equations, rational equations of this form, where you have basically a fraction equals another fraction, there's two options we can use. We can either use it as a proportion and say the cross product of that is equal to this, or we can use the LCD to get rid of the denominators on both sides. So it's basically like solving an equation that has fractions. So we have two options. We either set this cross product equal to each other and solve, or use the lowest common denominator, which would be the two factors in the denominator, to get rid of the denominators. Whatever it is that we use, the last step always in a rational equation is to make sure you check your solution in the original equation or a problem to make sure the denominator doesn't become 0. So that's always your last task. So let's look at part A. It says solve this equation. So to solve this equation, I'm going to go ahead, I can either think of this as over 1 and use the cross product like I did over here, or I can use the lowest common denominator. In this case, I only see one denominator, and I'm going to go ahead and undo it by multiplying both sides by x minus 2. So I'm using the second option of multiplying both sides by the lowest common denominator. That'll help me cancel out or reduce those two, and I'll end up with 1 equals negative 1 times x minus 2. From then on, I can distribute 1 equals negative x plus 2. I'll subtract 2 from both sides. Negative x is equal to negative 1, so x looks like it's equal to a positive 1. But before I box my answer, remember the last step is always check to make sure this solution that you got doesn't make the denominator of the original equation equal to 0. So I take this 1 and I put it in this denominator, and I test 1 minus 2 is equal to negative 1. That's not going to make the denominator 0. So if it doesn't make the denominator 0 and you've done the rest of the math correctly, x equals 1 will be the solution to this problem. Now part B, I can do the same thing. I can multiply both sides by the lowest common denominator, which in this case will be the factor 5 and the factor 4x plus 1. So multiply both sides by that. Or I'm going to go ahead and use this first method of the cross product for this one. I'm going to say the cross product x plus 3 times 5 is the same as, set it equal to 3 times 4x plus 1. So when I do that, I have 5 times x plus 3 is going to be equal to the other cross product, 4x plus 1. So again, either multiply both sides by the LCD or cross product, for both of them would have worked. Distribute 5x plus 15, distribute 12x plus 3, get the x's on the same side. That's going to be 15 equals, looks like 7x plus 3. Subtract 3 from both sides. That's going to be 12 equals 7x. Divide by 7. And as of right now, we're thinking x is equal to 12 over 7. But I'm going to have to go check it in all the denominators that have a variable term to make sure it doesn't make any denominator 0. So if I take this guy and I put it in this denominator, I'm going to get 4 times 12/7 plus 1, which again, when I simplify it, it's not going to be 0. And that's my main concern. I don't want zeros in the denominators to make things undefined. And this denominator doesn't have a variable, so I don't need to put it there. And my answer, if I've done the math correctly, must be x is equal to 12 over 7. Okay, part C, still we're supposed to solve the equation. Again, I can put this over 1 and do the cross product if I want to. So either the cross product or LCD both sides, doesn't matter. You're going to get the same answer. Let's say I do the cross product of the two. That's going to give me 6 times 1 equals x times 2x plus 1. And that'll be 6 equals, distribute that, 2x squared plus x. Since this is a quadratic equation, I'm going to go ahead and set it equal to 0 and then see what we can factor. There is no GCFs and the 2 doesn't get pulled out, so I'm going to multiply it up by the negative 6 using the while method of factoring, x squared plus x minus 12. Now I want a product of negative 12 and a sum of positive 1. So it looks like 4 and 3 will do. Positive 4 and a negative 3. Set each factor equal, oops, not yet, I forgot something actually. Since I multiplied by 2, I gotta go back and divide these guys by 2. That's a key step in this method. So I have x plus reduce 4 over 2 to be 2, and this doesn't reduce any further, so move the 2 up, and that'll be 2x minus 3. Now I can pop out my solutions. X plus 2 is 0, or 2x minus 3 is 0. That's going to give us x is negative 2. I have to check it shortly. Or x is 3/2. I'm not going to box either one until I go sort of look at the denominator right here and maybe mentally check to make sure the denominator doesn't become 0 when I plug it in. So both of these go back into the denominator. Wherever denominators there are x's, you check them to make sure they don't become 0. So when I put a negative 2 in, I don't get a 0. I get a 2 times negative 2 plus 1, so that's good. And when I put in a 3/2, I get 2 times 3/2, 2's cancel, 3 plus 1 is 4. So neither one makes the denominator 0. That means I have two solutions. Both of them work. Let's go look at part D. Again, I have the option to do the cross product. So if I want, I can do this times this times this guy times the other guy. But notice what happens. I'll have x times x plus 1 equals x plus 1 times 2x plus 1. If I do the cross product, this is going to give me more work. I'm going to have to multiply things out, get quadratic equations, set them equal to 0, and so forth. If I use lowest common denominator method, let's see what'll happen. Let me start with the same problem. X over x plus 1 equals 2x plus 1 over x plus 1. Notice how they have the same exact denominator. So I'm going to multiply both sides by that lowest common denominator, which is x plus 1, x plus 1. Multiply both sides by that denominator, and right off the bat, these guys go away, and I get a much simpler equation to work with. X equals 2x plus 1. So instead of doing the cross product and multiplying, for this problem it turned out to be easier if I just used the lowest common denominator. Now I'm going to go ahead and solve for x. Negative x equals 1, which means x must be equal to negative 1. Now again, I don't box it, I have to check it in the original denominators to make sure it doesn't become 0. And notice what happens when I put negative 1 in here. Negative 1 plus 1 becomes 0. So if it becomes 0, it becomes undefined. Even if I put it in this one, it still becomes 0. So this actually gets tossed out, since makes denominator 0. And we actually have no solution. We only found one possible one. It didn't work, so this problem has no solution. No matter what x value I try, I'm never going to get a true statement, and negative 1 makes it undefined. So this problem again has no solution.